We concluded the previous presentation by introducing recent James Webb Space Telescope images of the Сейферта 2 galaxy NGC 7319 within Stephan's quintet. Before moving to those images, we need to talk a little about dust and its relationship to telescopic observations. In the absence of any obscuring matter, the intensity of light emitted from a light source diminishes with the square of the distance. Light in the visible portion of the spectrum can be further diminished or even extinguished as a result of being absorbed or scattered by matter between the source and receiver. Infrared light can penetrate through dust that is opaque to visible light. The image on your screen compares visibility in optical and infrared light in a smoke-filled room. This is a relevant example because smoke from a fire is not purely a gas. In fact, its major constituent is particulate matter, and those particles are tiny, just as dust particles in space are tiny. This image shows how even a relatively small amount of dust can effectively block visible light, while allowing infrared light to pass. In 1784, William Herschel was heard by his sister Caroline to explain, "Here is truly a hole in the heavens." Herschel was referring to a dark patch in the constellation Ophiuchus, where no stars at all were visible in the field of view of his telescope. Herschel was convinced that what we now know as molecular clouds were what he termed vacancies, or regions of space devoid of stars as far as the telescope could see. That became the prevailing view among astronomers, and was only finally overturned when in the early 20th century, Edward Emerson Barnard assembled a body of photographic evidence showing that the dark regions in the Milky Way were opaque clouds of dust that block the light of background stars. The history is recounted wonderfully by the radio astronomer Gerard Verschuur in his book Interstellar Matters. In this set of images of the dark cloud Barnard 68, the first two are within the range of visible light. The remainder, moving clockwise, are at increasing wavelengths of near-infrared light. This is a comparison of Hubble images of the pillars of creation, with a visible light image on the left and a near-infrared image on the right. Notice how the relatively tenuous bluish-glowing gas and dust surrounding the pillars effectively blocks the visible light from all but the brightest background stars. An ESA feature explains how dust affects what a telescope can see and how that is dependent upon the wavelengths of light being captured. Quote, "Although our eyes cannot see infrared radiation, we can sense it as radiant heat. Infrared radiation is heat, and all objects, even the coldest ones, an ice cube for example, emit a certain amount of heat. In fact, celestial objects with surface temperatures of about 2000 degrees Celsius, cold compared to the Sun, which has a surface temperature of about 5500 degrees Celsius, radiate most of their energy at infrared wavelengths. The cool universe is best studied in the infrared. Dust is the bane of the optical astronomer's life, blocking the view of many interesting objects. The universe is full of dust, microscopic particles of varied composition, carbon, silicon, water ice, minerals, frozen carbon monoxide, organic compounds, silicates. The list is almost endless. The particles can be hard or soft and come in many different shapes, but their size is usually less than 1 micron, or 1,000th of a millimeter. The wavelength of visible light is much the same size as many dust particles, so it is easily blocked, that is scattered by the dust, whereas longer wavelength infrared radiation passes through unhindered, and dust is therefore transparent to it, and in the far infrared, we see the glow from dust itself." Unquote. When dust scatters light, we may see some of that scattered light as a reflection, just as we see in the glowing dust around the pillars of creation, or in the most famous reflection nebulae, the nebula surrounding the Pleiades. However, as noted in the ESA feature, in the mid-infrared, dust ceases to be transparent to infrared light and instead becomes visible on account of its own thermal emission. In these wavelengths, a space telescope can capture the glow of the dust itself. This is a spectacular example, with an optical image of the constellation of Orion on the left and a mid-infrared image of the same field on the right, revealing extensive clouds and filaments of glowing dust. This is Webb's MIRI and NIRCam composite image of Stephan's quintet, with the relevant portion of NGC 7319 indicated by the box. This is that portion of the Webb MIRI and NIRCam image centered on the quasar. Notice that the quasar is surrounded by a halo, with image processing to enhance contrast and saturation. The halo clearly has a hexagonal shape. A James Webb technical document illustrates the morphology of artifacts produced in both the MIRI imaging system and in the NIRCam imaging system. Undoubtedly, the hexagonal halo is an artifact of the telescope's optics, primarily from the longer wavelengths of MIRI. Here is a larger view of NGC 7319 from the Webb MIRI and NIRCam composite image of Stephan's quintet, with the quasar indicated by the arrow. Note the prominent filamentary dust lanes. Here is the same region, this time from the Webb NIRCam image only. Note the filamentary dust lanes have all but disappeared. It is plain that they are contributed almost entirely by the MIRI image. And here is the same region again from Webb's MIRI image only. The dust lanes dominate this image. Note that the quasar coincides with the dust lane. Comparing the MIRI and NIRCam images side by side, we see that the dust lanes in NGC 7319 are prominent in Webb's mid-infrared MIRI image, and all but invisible in Webb's near-infrared NIRCam image. This is precisely because Webb's MIRI instrument was capturing mid-infrared light emitted by the dust itself, whereas Webb's NIRCam instrument was capturing near-infrared light with wavelengths that pass through the dust, rendering it largely transparent at those wavelengths. Moreover, dust sufficient to produce the pronounced glow recorded in the MIRI image indicates a column density that would, on any view, be sufficient to block visible light from a distant background visible light source. Just as the comparatively trivial amount of dust in the vicinity of the pillars of creation, seen in visible light as a reflection nebula, was able to block the visible light of almost all of the background stars. The Hubble images of Stephan's quintet, released in 2000 and 2009, were both essentially visible light images, albeit that both include light from filters at 814 nanometers in the very near infrared. Those Hubble images demonstrate one simple, key fact. The quasar is bright, invisible light. This collage shows the same close-up field, centered on the quasar, from Hubble's 2009 visible light image at the top left, Webb's mid-infrared MIRI image at the top right, Webb's near-infrared NIRCam image at the bottom left, and Webb's MIRI and NIRCam composite image on the bottom right. In the NIRCam image, the relevant dust lane is not visible. Near-infrared light from the countless millions of stars in the body of the galaxy is not obscured by dust to any discernible extent, just as we would expect. However, the Webb MIRI image and Webb MIRI and NIRCam composite demonstrate that a substantial dust lane, seen by its own glow, extend all around the quasar. As stated, this demonstrates the presence of dust sufficient on any view to block the visible light of the quasar captured in the Hubble image if that visible light was coming from behind the galaxy, let alone from more than 9 billion light-years behind the galaxy. In the Hubble image, the dust lane appeared to coincide with the quasar, but there was still some room to debate the matter. The proposition that the quasar is a deep background object shining through the whole disk of the dusty Сейферта 2 galaxy NGC 7319, including the substantial dust lane, captured in visible light by Hubble, seen in both the WFC2 image released in 2000 and the WFC3 image released in 2009, is quite simply preposterous. In summary, the Hubble and Webb images of the quasar associated with NGC 7319 are observations that simply and unambiguously prove that the high redshift quasar is a foreground object. These observations falsify the redshift distance relationship. the foundational axiom upon which the whole edifice of Big Bang cosmology is erected. The wisdom of Edwin Hubble's caution is demonstrated, and Хэлton Arp is vindicated yet again, just as I predicted. However, standard model astrophysicists and cosmologists will continue to insist that the quasar is not in front of the galaxy and must be a background object shining through the galaxy. If they don't, they will be forced to admit that these observations destroy the foundation of Big Bang cosmology. It's a textbook case of paradigm paralysis. But as Chico Marx might have put it, who are you going to believe? Them or your lying eyes? Of course, the quasar in NGC 7319 only adds to the numerous examples that Arp and others have produced, demonstrating unequivocally the existence of physical connections between objects with wildly different redshifts, like the connection between the low redshift galaxy NGC 7603 and a high redshift quasar, a connection established even more convincingly by Martin Lopez Corredora and C.M. Gutierrez, who obtained the images you see on the screen. Or like the connections between NGC 4319 and Markarian 205. A physical connection between these two objects of very different redshift was first imaged by an amateur astronomer in 1970. Хэлton Arp demonstrated the reality of that physical connection in a paper published in 1971. In 2002, the Hubble Heritage Team at the Space Telescope Science Institute released the image on the left showing no connection, and accompanied by a commentary stating, "Appearances can be deceiving. In this NASA Hubble Space Telescope image, an odd celestial duo, the spiral galaxy NGC 4319 in the center and a quasar called Markarian 205 in the upper right, appear to be neighbors. In reality, the two objects don't even live in the same city. They are separated by time and space. NGC 4319 is 80 million light-years from Earth. Markarian 205 is more than 14 times farther away, residing 1 billion light-years from Earth. The apparent close alignment of MRK 205 and NGC 4319 is simply a matter of chance." However, image processing of the STSCI's own image file by Bernard Lempel, shown on the right, brings out the bridge of matter physically connecting these objects. In each of these cases, and many others, a physical connection is demonstrated between objects with redshifts so different that such a connection is utterly impossible on the Big Bang's foundational axiom. These examples, as powerful as they are but one component of a vast body of evidence accumulated by Arp and others that falsify the Hubble relationship and establish that cosmological redshift is intrinsic, that quasars are ejected from active galactic nuclei and evolve into galaxies in quantized redshift steps.